Good thing to... Tu peux me tenir le micro 2 secondes? I need a microphone holder. No, where my mouth is. Yeah, it's your mic, so... And I think I know why. It's augmented sound. Well, it's off. For whatever reason. For that reason.
I call it sabotage.
Sabotage.
German with the French always doing some twisted at the end.
Good thing your mic is not on.
Yeah.
You'd be in trouble for that. I think we should hear you now. Wait. Say again? Say something.
Yeah.
Okay.
I said the German and the French. No, sorry. I did not.
So hold the mic again for like a minute or like 10 seconds. Quick little tip which I discovered a couple of 2 days ago is if you have a lot of screens like I do right now, 3 screens, and you want only 2 of those to mirror but not the third one, you hold command and you drag and it doesn't work. Or shift? Is it shift? Option. Thank you. Thank you. Option. On one of each other, and then you only have 2 mirroring and not the third one. So which is pretty awesome.
Thank you. Have a good day. Bye.
Now the not so awesome part of it is it's the confusing UI of having this checkbox saying mirror displays, because it actually doesn't really, because one of the display is not mirrored. It should be like a minus or whatever. Anyway. File a radar or get the fuck out. There is kind of a tradition at Objective Cologne and SwiftConf, which we almost left this year, which is to always have some kind of frog on stage. And so there is always a French guy on stage at one point. Yeah, a frog. A French guy. Right? That's the way to put it. No, we don't eat frogs. We eat fries. Starts with the 2 same letters, but there's no... Is it online?
I'm working on it.
You're working on it. Yeah, I'll show you at the next break. And so, yeah, this year, as you know, Paul Hudson couldn't make it. So I basically did what I do when I need to find a very talented French speaker. I asked Franck, and I was writing to Franck and asked him, so who would you know? And one of the guys he mentioned is here. And I had seen you actually at .swift. And not only had I seen you, but we also had dinner after. And it was very funny, so I was sure, like, I don't know if it's going to be any technical, but it's going to be fun by any means. So let's have a round of applause and let's hear about ARKit.
Thank you. So, well, thank you to get me here. So I'm going to talk today about ARKit in a kind of a different ways from what you may have already seen. If anybody have seen the haha take on me video or whatever, like when they do AR, forget about that. I'm not going to show you any of that. It's not going to be like it's about UI in ARKit. So I mainly are a UI developer for iPhone, and how can you be an UI developer with AR? So my name is BERNET-ROLLANDE. Here's my Twitter and my GitHub. I'm a freelancer iOS developer, and I've been working mainly, I mean, a little while now with iOS, but mainly recently on BLE and Bluetooth technology, which I think can also overlap a bit with AR at one point. So let's see what we're going to talk about. So we're going to have a brief overview of AR technology. How does it work, briefly? And the main classes, the framework, the main classes that you're going to use when you work with ARKit. Then we're going to talk about like 2 ways to use ARKit. There's multiple ways. Today is going to be SpriteKit and SceneKit, because basically AR is about like building a virtual space in the world. So there's multiple ways you can bring this virtual space. We will talk about SpriteKit and SceneKit. And after we'll go over same thing if the god of demo are with us, but like two, not one, two UI demos, so one of them not going to work. And then we want to go over some limitation, take in consideration that ARKit is really, really an early framework, and actually it should not work right now on iOS. It's pretty incredible that Apple have made it work, so it is limited, and that's big limitation for now to be taken in consideration. And then after, we'll just quickly review if you want to do more about ARKit, where you can go. So, quick overview of the technology. So, they use something called visual inertial odometry, inertial odometry, which is basically like taking an image and trying to make sense of it, what this image means into the world. So, if you have only one image, it's pretty hard. But what they do is they try to find little point that they think were the same point when you just move a little bit your phone, like just holding it like that, you're already moving. If you have Parkinson, it works way better. And the thing is, like, they will try to say, like, well, I was here, I saw that point, I move a tiny little bit, I saw that point again with a little difference, then it probably means it's 2 meters away from me in this direction, and so on and so on. So for that, they couple it with the inertial measurement unit, which is basically all the core motion thing, the accelerometer or whatever. So they can know how the phone moves, and based on that, they can try to find what the world is, how is it. And there's another thing that is more about like core ML, which is called dead reckoning. It's basically making a guess. So let's say you move your phone like this, before the calculation and all the core motion data have been processed, they're trying to make a guess. Well, I guess that's what it is now. So that's in order to be really fast and still continue rendering without dropping frame. So that's the one that something go fucked up, and like all this, can we say fucked up? Yeah. Sorry. The French, and they're trying to make a guess what it is. And so all of that bring you what they call a 6D model. It's not a word from Apple, even if they're probably going to patent it. It's more like about like AR and SLAM technology, which is about like building AR world. And it means you have a 6D, so you do something like this. Don't forget one of the finger, otherwise it look weird. And that means there's a translation in the 3 direction, so 3D. But there's also rotation in the 3 direction. So that's why they call it a 6D model. So based on that, it's mainly like a transform that tell you where you are and where is that feature point in the world. Some of the ARKit unique feature compared to other frameworks, they all, I mean, like other technology like HoloLens or whatever, they do 2D plane detection. So far, it's only limited to horizontal plane, so the ground, not the wall, not vertical plane, which is already kind of pretty neat if you try to put stuff in the real world. They do metric scale, which allow you to have basically like to say like, well, I want to put an object and I want this object to be 1 meter wide. Well, it's just, you give it 1 and it's 1 meter wide. So the unit is meter, and it's really convenient if you deal with real world object. Light estimation, as you probably all have seen in the keynote and State of the Union, which is basically like trying to make your object fit in the scene as if it was part of the scene. So they're going to try to render it as if the lighting was the real lighting. And finally, one of the main, for me, feature about AR, because I'm not a 3D developer, is the easy integration with SpriteKit and SceneKit, which like, those frameworks are pretty basic for what you want to do in AR. It's really easy to learn, and you can already do so much without going into like big like Unity and AR, like real AR component. Of course, you can use Metal and other like custom renderer, but that will not be part of the talk. So ARKit. So the main classes of ARKit, there is not a lot actually. There's AR session configuration that is the way for you to tell to the device what you want to do. There's 2 main kind of AR, which is like, I want a world space, which is, I'm here and I want to just put an object 3 meters away in that direction, which is the most convenient, the most easy one to do. And it doesn't require, it requires less capabilities of the device, so it will work on more devices. And even like if the image is poor quality, it will still work with lower lighting and so on. Then there's world tracking, which is the one we talked about with, for example, plane recognition or whatever. And that's just another setting that you will say like to the ARKit framework, I also want this. So we will see how to do that. The AR session is basically the beast of AR. We will process all the frame that come from the camera, merge it with the core motion and try to make sense of where is the word. And it will put like something we will see just after, which are called anchor, which will give them like 3D spaces, 3D point into the world. AR frame we just talked about is like, it's just a frame of the camera, but that is processed in order to make sense of what they have seen. Take in consideration toward what we were saying before with visual odometry or inertia. Visual odometry, you will not have a lot. You have 30 frames per second, roughly. But core motion, you can have 1,000 measures per second. So that's where the AR frame combined to the AR session can go really fast in order to process all those information. The AR anchor, as we say, is basically you can have a lot. It's basically a point in the real world, in the real space, that ARKit will track for you. So once you find this point, you will attach stuff to it. You will build a 3D scene or a SpriteKit scene, and then you're almost done, because ARKit will do, when you move around, it will do all the transformation that need to be applied to that specific anchor to still mean the same thing in the world. So now I just 3 meters away instead of 2 meters. Well, ARKit take all the math, do all the math for you. So go a little bit digger into further into each classes. So as I said, manage the AR processing, reset the tracking, which is also important because that's one big issue with ARKit for now, is like, if, for example, somebody called you or you quit your app or whatever, well, you just lost the world, basically. So if like your phone is moving and like I said, you lose at one point, you have to reset the session, and all the anchor don't mean anything anymore because they don't have a real notion of where they could be passed from before. So that's one way you can reset the tracking also, or like if, for example, you have lower condition, like less light or so on, well, you will reduce what you wanted. You don't want the plane detection anymore, you just want the real space. And session update, it's through a delegate, of course. ARKit will call you back each time you process a new frame, and that's an opportunity for you to do some work, for example. After the AR frame, as we say, like it's basically like just a camera image background. So it will be displayed in the AR session. It's not necessarily mandatory. You could say like, I don't want to display the background image. That would be a weird AR experience. But that's where the point's going to be, or the tracking location, the send estimate, and so on. So take in consideration the fact that the camera, that's how it's facing, like the Z is in fact, the plus Z is behind you and the minus Z is in front of you. So we will see, it could be like weird sometimes to think about that. But AR anchor, so that's basically the only thing you care about ARKit, because it will be like, once you find a point in the world, whether it's a physical point, based on the real world, like a plane, or just a space point, an AR anchor contains all the transform, the rotation, the translation, and so on. So you will attach something to it, and you're done. And they mainly manage all of the transformation after are managed by ARKit. So you don't move anchor. You try to find them, they're given to you by the system, and after you can positionate element relative to that anchor. Okay? And so ARKit can also create some anchor for you, like when you do plane detection, because it will tell you like, well, instead of just saying, oh, I want an anchor 2 meters away from my camera at this orientation, ARKit will tell you like, well, I find a plane, that's where the anchor of the middle of that plane. And after you can put object at this position or another translation and so on. So that was a really, really, really brief overview of ARKit, but it's almost all you have to know about ARKit. After, it's more about the two other frameworks that we're going to talk about, which are SpriteKit and SceneKit. So they have been introduced a little while ago. Once again, I'm not a game or 3D developer, so I haven't really played with it like before, like recently. But for what you're going to do in AR, like you only need to know like 5–10% of the framework, and already you can do pretty much everything you will do in UIKit, with obviously less synthetic sugar already there. But like position content, interact with this content, move the content, do action, and so on. The difference between the two of them, 2D, 3D, SpriteKit can be a bit weird in AR because, well, we live in a 3D world and SpriteKit is 2D, so how is it rendered? It's not necessarily the best yet, but we'll see that there's some ways to hack around it to make it seem like a 2D scene in a 3D world. So we're going to start with SpriteKit because I think it's the easier one to jump in. And also, if you want to build UI, I mean, I haven't seen that many great 3D UI, but I've seen amazing 2D UI, and so that's what we're going to focus a little bit to start with. So SpriteKit, a little primer. So same thing, obviously there is everything is SK, SpriteKit, SK view, which is just a subclass of a UI view. And it can be really convenient also because, well, it's a UI view, so you can put control in it if you want. But it's also the one that holds a reference to the scene, which is where all your drawing, your SpriteKit drawing gonna happen. The scene itself is the root node of all the elements. So we're gonna see after a bit more what is a node, but basically like that's the first reference from where all your point gonna be positioned. So you have your scene, which is like the middle of the world, and after you position related to it, and after you can put position related to this one, but at the end they're all related to that root node, which is the scene. And it's also the scene who hold all that nodes tree. The node for SpriteKit is just basically a reference point. In this case, a 2D point that say like, well, I'm at this position, I'm 3 and 2 from here. That's all what it is. And obviously you have a bunch of subclasses to display sprites, so image, text, and so on and so on. There's a bunch of other classes in SpriteKit that we will not necessarily explore fully, but we're just gonna mention them. SK action, which is like, it's a way to say like, well, I wanna do that kind of movement on a node. You programmatically say like a translation, a rotation, even if for SpriteKit it's not necessarily in 3D, and so on. And then after you can combine, it's like a SEA, if you know like SEA car animation, it's kind of the same idea. And you can repeat them, you can group them, you can chain them, you can sequence them, and so on. Transition, same thing, it's not necessarily useful for AR, but you can have multiple scenes. So if you were in a SpriteKit game, you can have one scene for the intro, then you transition to your game, and then you transition to the next level, and so on and so on. You can do that, obviously, also in SpriteKit, but for the UI that we're going to talk about, it's not necessarily required. And texture, just apply a texture to one of your nodes. After Apple, because it's their framework, I've give you like the same thing as the UI table view controller, which is a table view and a UI view controller merged together. They gave you a AR SK view, which is basically an SK view with already a session in it. Honestly, I have nothing better than that, really. Do that, it's already like set up for you, but it's still a good like convenient things to use. And like all the model of Apple, all the example of Apple are built on that. So don't be surprised if you see that class, it's nothing else than the merging of those two things. And after we just talked about like anchor, the node, well, the main point, the main game in ARKit is to link the two. So ARKit will give you an anchor that either you have found or either you decide to say it's at this position. And after you are going to associate an anchor with an SK node, which can be a sprite, can be the root scene, can be another element to add to it. And that's how you build your scene. After, the anchor will change in terms of transformation and rotation that need to be applied, and ARKit will update the node that are attached to it. And that's pretty much it. So, if the god of demo are with us, well, I'm just going to show you that the next screen was demo, sorry. And so, yeah, so left, right, Can I do this thing full screen? That's not necessarily going to do any, a little bit better. So I just broke my phone coming here. I'm actually going to sue 7 for them. I hope 7 Principal is going to pay for it. But so the UI, the touch gesture, I just tried it and like it seems to work, but if it doesn't, we will see. So we're going to start right away. I hope you see you all. And if things work, hello. So you will have overlay a bunch of photo of my daughter and my son. Just FYI, the best game we have with my daughter is actually to make fun of, see, that's her little brother, and she just put a weird hat. It's actually her pants on her head. And so I was thinking like, okay, that's how I can explore all my portfolio. So that's one scene here that I see, and I can go through and based on the camera's position, I can like change the size of the image to see it a little bit more better. But I also have another one here. So the same photo, but you can imagine it will be different photo. And also I can have another one here. You could have one in the back, wherever. So here, what I do is like, I have my SpriteKit scene, but I use mainly my phone as a controller to say like, what am I doing? What am I overlighting? It's not anymore you touch, it's your eyes or your phone acting as a controller. And we will see after how to do that, but they're still like touchable. So here I'm gonna touch this beautiful photo of my daughter because it's the main one, but I could touch somewhere else. For example, here, or here, or here, at other part that I'm not highlighting on the screen, and it still work. And we'll see why it work, but it's pretty, I mean, it's just a touch event. So if you know UIKit, you already know almost everything to do what I just did. So good, this demo worked. That's a good thing. And I don't know where's my mouth. Oh yeah, that's really hard to do actually. Yeah. I'm gonna move that back. Choop, choop, choop. And it working? Great. So that was a tiny demo about SpriteKit capabilities that I just actually had another one, and I just built it during lunch and a bit before. So it was an hour and some change. So it's really easy to work with it. So what are the different steps to use ARKit with SpriteKit? So as we said, the first thing is to position your content using an anchor. So you get an anchor from the system, or you positionate an anchor relative to the camera. That's the first step. For SpriteKit, it's a bit weird. You don't put directly content. You add an anchor to the session that you say, track me that thing. All around now, from now and ever, I want you to track that thing around the world. And after, you will have a callback through the delegate saying like, oh, I have an anchor. What do you want me to put here? So you say, well, I have a node. And a node can be a scene, can be a node with sub-nodes. So it could be like all that image that you saw was with all the different images was just one big node with a bunch of little nodes. Same thing, after I did a transformation, so I had one anchor that was 2 meters away from me, and I applied a transformation, a rotation to put it here, and I put another anchor. Put it here, I put another anchor, and I got my 3 main nodes that contain all the different images. After, you want to, obviously, it's better, interact with your content. So we will see a bit, but like SpriteKit is pretty efficient for that. That's why like a lot of developers have, especially UIKit developers have enjoyed playing with it, which is it's just a UI responder, the SK node. So it's actually begin touch will work with it. You can add gesture to it. I mean, there's really nothing else to do. We will see it's a bit more complicated for SceneKit, but for SpriteKit, you know how to do UI in UIKit. Well, you know how to use SpriteKit. Then for you know how to use ARKit. So end of the talk. Goodbye. Almost. The camera position is interesting because it's a new UI. It's a new UI interaction. So by moving my phone around, I'm actually saying something to the system. I'm saying like, well, I want to know more about that element. That was just the way I highlight one of the content by make it grow. But I still have the phone in my hand. So I could say like when I apply a gesture, which is a pinch, a pan or whatever, well, it could apply to the element that was focusing. So you actually combine 2 interactions within a same experience. The moving of the device and the touching of the screen that is actually like interacting with the content that you've decided is the one that interests your user. And after, you just convert point back and forth. So we'll see, but ARKit and SceneKit, SpriteKit, sorry, give you like convenience method to transcribe a point to say, well, I touch the screen here. What does that mean for my scene? And then for which node did I touch, if you don't want to use UI responder or if it's a different type of interaction. And that's all. ARKit will do the rest. So if any of you know SpriteKit, so which probably said like, that's wrong what he said, that's not at all how it works. Well, sorry. Well, then you're good. Because with what we just saw before, the anchor or whatever, and with that, that's really all you have to do. So let's see a bit more about the code. So here I declare, I'm going to try something, I'm going to do something silly, which is I want to fix screen position. So nothing to do with AR. I want to put something on the screen, not in the world. So you could, that's the second one, you could just put an UI classes, because we saw that SK view is a UI view, therefore you can put a classes. You can put a label, you can put a touch, you get a button, you can put whatever you want, it will work because it's a UI view. You can also, because it's still SpriteKit, you can also add any node to the scene element. But here, you haven't given ARKit any clue about where in the physical world you wanted to put that element. So that element is not in the world, it's in your screen. So that's how I did the little red and blue, was it blue? Yeah, blue circle that was highlighting which content I wanted to focus on. It's just a point in the middle of the screen. By default, the anchor point, which is not to be mixed up with the AR anchor, which is basically where the content is going to be positioned from in a scene by default on the screen, is in the middle of the screen, so you will have a blue circle in the middle of the screen. Not really AR, but still good to know. After, how do you put content relative to your camera current position? Well, here you need information about the camera. So first of all, you need to be sure that the session has started. That's what we talked earlier about the fact that the session have a delegate that can inform you what it is doing. So it will tell you like, well, I'm starting to detect some stuff. When you detect some stuff, you add some frame. When you have some frame, the frame also have a camera which contain all the information about where this camera is in the world, in its space, more to say. Once you have that, so here, I get the camera from the current session, the current frame, I get the camera object. After, that's where there's a bit, there's not math, but there's a bit of things that do math. So you build a 4D matrix, a 4x4 matrix, which is basically, we're not going to talk about matrices here, but like if you know about it, it's basically a way to apply transforms to things. You can do rotation, translation, and so on and so on. So here we build an identity matrix. Then this matrix, we say now you're not anymore an identity matrix, you're a translation matrix. We want on the Z axis that you go backward from 1 meter. I didn't say any units, but in SpriteKit, in ARKit, it's meter we talked about. So it's 1 meter. And it's not backward, as I say, in fact, it's in front of you. I don't know why the heck they will have done that, but it's in front of you, and it's negative. Yeah, you know, you do the 3 thing, yeah, whatever, the other finger. So then after I create my transform by multiplying those matrices. I take the camera matrix, which is here, right? It contains all the information about where I am, where this camera is in the space, and I apply my matrix transformation that say, now you translation 1 meter away from the camera. So now I have a matrix that contains all those information, and I can create an anchor for it. I will create manually, that is the anchor, and I will add it to the session. From now on, until I remove it, ARKit, each time the camera moves, each time your phone moves around, will do all the math to update where is that thing based on where you are now, which is not that complicated. You move this, well, you apply this translation, this rotation, and so on this anchor. And you don't add the content right away. It's kind of weird how, but whatever. In Sprite, you don't add it right away. You just add the anchor point for your content. Then after you have a delegate that will call you back with a view and with the anchor that was added. And now you return a node that ARKit will attach to that anchor. Okay, so in that case, that was just a label, and the result, it's not really clear, is this little hello world in the middle of the screen, 1 meter away from me. And if I move the camera around, it will stay where it was until I come back to it. You may wonder, like, well, what if I have more than one hello world and a lot of things? Well, then anchor have identifier, like UID or whatever. And then you can find your little guy and say, oh, that was the anchor for this content or whatever, which still seems weird, but you can even do more, which is most of the time you will actually have one anchor here, and all your scene will be based on that anchor point, because you can also apply retransform on it, and so on. Hope it's clear. After, and we didn't show that in this demo about SpriteKit, but you can put element in the real world, not in the real space around my camera, but the real world, so the plane, for example. Hopefully Apple, we'll see about the release, but we'll do more, but we can hope that they will do like vertical plane detection, furniture, other things that will allow you to position content on other type of real world object. For now, you only have plane. So how do you do that? So here I assume that we had a gesture on the screen, we touch, and as you were to do in any other view, you convert. So you do like, oh, what was the location of my touch in my scene? You're gonna get a location, which is a 2D location still, right? Then after, you have a convenience method of the scene, the AR scene that will allow you to, the SK scene, that will allow you to do a hit test. So basically what you're saying here is like, if I had that point here on my phone, I want to project a ray toward the infinite, and I want to see if it cut anything on his way to the infinite. And if he cut a plane, then ARKit will tell you, yeah, he do cut something. Here's the anchor that it cut, or all the anchor that it cut, because it can be multiple. You can have different scene, the one after the one after the one, or different ground even, because you can have that chair and you can have that table and the ground here, for example. So here we take the first one, same thing, we had an anchor, and we return a node for that anchor that say hello world. Now that little hello world is on the ground, which is just over there next to that guy, and is still there, I think. And the thing is, like, you will notice that on the hit test, you can add, you can pass also some type, which is basically you can say like, well, I want to try to find object that cut and that existing plane. We'll see in a second what that means, existing plane. Existing plane with extend. So the difference is like, ARKit will detect a plane, and they can do what they call infinite plane. So for example, here, as you can see, the ground stop. I hope you can see that. And they will extend it as if you were going like up to Cologne. So you could put an object on that plane in Cologne if you want. If that's what you want to do, you can put an object 300 meters away, but on that plane. So that's the difference between extend and not extend. Extend means, well, I want to limit it to what ARKit know, that room. Not extend means like, well, I don't care, I could put it at the infinite. So it will cut, if I put not extend, it will cut even here. If I put extend, well, it will not cut if I try to cut in the void, in nothing. After, you can also cut with existing anchor that you already put. So as we saw before, you can add an anchor like 3 meters away from here or here, and after you try to refine them. Haven't really found the use case right now, but haven't looked more than that. But the question is like, well, where does that plane, like existing plane, come from? Because it didn't exist just a second ago. So remember when I was talking about the AR session configuration and the different mode you can start it in, the world space or the real world space? Well, when you put the real world space, right away, ARKit analyze all your frame and say, well, do I find something that looks like a plane? Oh, yeah, I think I find something. And he called you back. And he said, I created an anchor for you. That is the anchor of the center, the middle of that plane. You have nothing to do. You don't even have to set up the delegate. It just created for you because you did plane detection. You probably want to set up the delegate to know that, oh, the plane is detected, so now I can try to do a hit test against existing plane. Because if you do that and the plane is not yet detected, well, the result is going to be empty. After, when they give you back the anchor, you could try also to do something else as soon as they detect it. You don't have to try to cut it again. So for example, you detect a plane and right away, you want to put lava on the ground to do a lava game with your child, that some people may have seen also in another ARKit demo. So that's the little secret about those existing plane, existing XN plane, and so on. After, as I was saying, so now we all position all the content, beautiful photo, lava, and stuff in Cologne. Now, how do we interact with the content? Well, as I was saying, like SpriteKit, all the SpriteKit nodes, so the SK node, are UI responder. So they have touch begin, and that's all. It doesn't matter where this object is in your scene. If you can see it with your phone, you tap on it, well, the event is triggered. So interaction is pretty straightforward. regarding SpriteKit and ARKit. I wish it was a bit more complicated to say it costs more money to develop, but not really. The only thing is like you have to activate the ease user interaction enable, otherwise it will not work, and that's probably worth like $1,000 more. After, how do I interact with content in other way? Well, same thing, you can have tab gesture. You could have tab gesture attached to the SK node, but it's more like here in this scenario, I want to say like, well, I have a gesture, same thing, I try to get the location in my scene, and after that method just after, which is scene.node@location, is a SpriteKit method. Because already this point exists in the SpriteKit world, so you say, find me all the nodes that are at this specific location, even if they're behind or whatever, they will give you in the Z order, so the first that are closest toward you, and then you can start to process this, like make it like twist around, grow, as we saw before. And as I show in the demo, one of the last interaction you can do with ARKit and SpriteKit is with a device. So here, when I first wrote that, I was like, is that the right way to do it? Because session did update is each time there's a new frame coming in. Each time like there's a new frame took from the camera, processed by ARKit, you'll be called back here, which means like 30 times a second. And roughly. And so, yeah, it's fine. Like, I mean, he's doing like 1,000 more processing in the background for the core motion or whatever, so it's fine. And here, like, what I get is like, I just pick up the center of my view, of my device screen view, and I say, convert that point to a scene location. So it will say, from the device, I'm going in my SpriteKit world, and I'll try to find the location of that point that is in the middle of my device screen. And then I use the same method from before, which is give me all the nodes that is specific location. And after in the little ... that's why I say, well, those nodes need to be scaled up a bit bigger, and that's how that photo grew or shrink as soon as I moved on. And so that's all for SpriteKit. The last thing is like there's a couple of limitations, which is, once again, it's a 2D model. So I was showing like I have one scene here with all those photos, then I move and I see another one with a bunch of the same photos. I really like my children. Well, I wish I could just like say like this one is a bit tilted because I want to do like a circle around me. Well, that's SpriteKit. That's not SceneKit. That's 2D, not 3D. Yeah, but I'm in a 3D world. But yeah, but that's still 2D. So there is something called SK transform in SpriteKit, which technically allow you to do like some kind of 2.5D transformation. Don't fuck around with that, because what that means is like you will apply a transform, and each time the camera moves, this transform don't mean anything anymore. The angle is not the same. Everything have changed. So we'll reapply all the transform to mimic some kind of 3D stuff. Well, guess what? There's SceneKit for that. So stop trying to push further SpriteKit. Just go with SceneKit. So SceneKit is a bit more complicated. That's where like this haha. It's really great, that thing, like take on me. I have it in my mind now. It's a 3D framework. So once again, you're going to do that all the time. You're going to be like, okay, well, I'm here, but I go there. It's mine. It's a bit more hard to wrap your mind around. But for what we want to do with just basic AR, the good thing is at least the world is maintained for you by ARKit. So if you develop any kind of 3D scene and you know there's like some editor in Xcode to put some object in 3D or whatever, you just dump that in an AR session at the right anchor, you're done. If you don't have a designer, if you don't have a 3D designer with you, well, you're not done. So SceneKit Primer, same thing. You have a SCN view, which once again is a UI view. So on your screen, you can still add control and so on and so on. Then you have a SCN scene, which this class is just a subclass of NS object. It's not an SNC node, but it do contain the root node. And what happened, in fact, is like when you start a session, the root node is established as your camera. After you start moving around, well, it will maintain all the transformation to that first root node. So if you added something just when the session starts, at the point 0, 0, 0 in space and no transform or whatever, then as soon as you move around, well, your objects still stay here. So your root node is already kind of an anchor. It's the anchor of the start of the camera. And after, same thing that SpriteKit, you should start to be used to it. And that's one of the good things also about SpriteKit and SceneKit. When you learn one, you learn the other one at the same time. 2 for 1, like girls. But then you have SNC node that is the same thing. It's position in space, position and rotation. So same thing once again. You say, I want to put it here, but it look like this and like that. Okay, that's my node. And it contains this little transform toward itself. It's also a node tree, so you can add another object 2 points away from here and there. There obviously you can put sprite, you can put text, but what you want to really do in 3D is put geometry. So there's 2 extra classes that you need to know before digging into SceneKit ARKit, which is SCN geometry, which is basically like vertices. In the 3D world where I want to put a box and I want to put a tree or whatever, and it contains all the vertices of this 3D model. And the vertices by themselves are not really pretty, so normally you add texture or material to them. So it's SNC material, so it could be an image, a color, or whatever you can think about. It can even be like somehow some layers in the back, like CA layer type of thing, but we will not necessarily go into that. So same thing, SceneKit ARKit, same thing from Apple. They give you a convenience class. There is AR Scene View, which contains a scene. It's awful, those words. If I say view, you all understand, right? If I say session, you all understand. So we'll dump those prefixes. So we contain a view and a session. So once again, it's just a convenience like table view controller type of things. And after, for all you anchor, you try to match a node. And once again, once it's done, ARKit will manage all of that for you, all the transformation that need to be applied. And it's 3D, so it's better because it's a 3D world. And that's pretty much it. Second demo. Second? Yeah, say it like that. Second. I don't know where is my thing though. Where is my QuickTime thing? Yeah. With the right. So, Steph, MC make me realize something, which is it's 9:41. In case you don't know, we're really early, and I have the Wi-Fi on, and I didn't want the Wi-Fi because my wife have a tendency to send me texts to prove that she loved me. And I don't want you to see those texts, so I put it in airplane mode, and it's still showing up. But no, it's just the fact that QuickTime is on for the demo. It's pretty, yeah, pretty good to know. So, SceneKit. So, I hope the cable is long enough. I'm gonna try to get that thing. So, when I was in the US, I work at, oh yeah, a cup, great. I'm not giving it back. Huh? Yeah. So, okay.
Well, we need to give it back.
Oh, true. Yeah. Well, that's your problem. So when I was in the US, I worked at a company that was basically doing like exchange between people, like shipping object or whatever. And one of the biggest issues that we had is like we built that awesome flow for people to post item on, but after we said like, what is the size of your item? Is it like roughly that, this and that? That's not really convenient to show in an UI. And like if you show a box in an UI, well, that's just on your phone. That doesn't mean shit. So people will always pick the wrong box, which means always pick the wrong FedEx box, which means always having extra costs, which means we will pay for it. And they were actually like probably having like smaller sites just because they wanted us to pay with. So then I thought like, well, if we had AR at the time, what could we do? Well, the first thing we can do is like detect plane, like I say. So here, like this little focus square, when it's open, it means you haven't detected a good plane here. And after, it's magically, yeah. So it means like, oh, you have detected a plane. So I'm going to add a little box. So if it works correctly enough, you can say, okay, that's a box that seems to fit roughly. Yeah, I'm going to move it a little bit around. It could be smaller. Yeah, no, it's not too big. Oh, no, it was too small. I'm going to make it a little bit big. Not too big. And yeah, I'm going to say, well, that's roughly the size of the object that I want to ship. So now I can tap on it and tell me, oh, well, no, You have a fitted box and it's $35. Cool. I'm going to put my next item. So does this one work? Yep. Same thing. We put it here. It's in smaller. Yeah, I'm really gonna make it like cheap. $29. Good. 35, 29. And let's see the cup of coffee. How much that thing will cost to send? Coffee is expensive, true. So I will ship it in a big box. So, oh no, it's too big. Now we can't ship that big of a box. It's all red. No, so I'm gonna make it smaller, smaller, smaller. Broken screen, doesn't work. 7 Principal gonna pay for it. $23. And so what is cool is like my UI is here. I mean, it still stay here. Like I could like send a bunch of other box and come back to this one and say, no, in fact, you know what? I'm gonna screw them. I'm gonna pay less than that. Yeah, that's better. It's still there. No going back to another view. No going back and forth. Just say like, well, you move around and so on and so on. I could do that for a little bit longer, but that's gonna start to be annoying. I know. So I'm gonna stop here. So, with my hand in front of it, perfect. So that was the second demo. Thank you. And so that's what I meant by having like enriched UI, which is, it's not necessarily applicable to all the scenarios. Like I say, for the SwiftConf one, I find to find better scenario, like I want to attach it on the wall. Well, they don't do vertical detection yet. Shit. I'm going to put it on the ground. I'm like, nah, it's not going to be cool to have an UI on the ground. Not yet. So, you know, you have to think a bit more of some scenarios, and that's why you probably need to work with some designer that can code, you know, because you dump them into ARKit, and I'm sure they're going to appreciate that. But I'm sure you can build like interesting UI. Here, obviously, if you relate to the real world, well, it's a given. Like you should try to relate to the real world. Apple have already published some interface guideline because they're always ahead of that with like, we want to control what you should do. So they say, for example, well, the AR experience should be a full screen experience because you could put it on only half of the screen. That will look really, really weird. But you know, you could build a mixed up of UI because as we saw, they're all UI views. So you can have control that, oh, well, I can still have my button to say like, ship it, but I put my box here. You can do interesting mixes. But I'm not a designer, as you may have seen by my beautiful design right now. Those boxes were free, by the way, on 3D things. So you have a bunch of 3D content available to you. So if you want to put dinosaur or whatever, like that's pretty easy to do. Like dinosaur boxes that will deliver whatever. So how to use SwiftConf with ARKits? What are the different steps? Well, you're going to start to get the rhythm here. You position your content using AR anchor. What they are? Well, they're either related to the camera, they're either related to the ground, they're either like invented. You could imagine that, like, say, like you just need one to do all the transformation to have a bunch of others. Then you add your SK node to it, and the good thing with SwiftConf is like it's easier to just put them. You don't necessarily have this weird clunky delegate system. Then interact with your content. Here I put UI gesture because I think it's still valid. For example, here I pinch and I move my boxes around. You may have not seen me touching, but it was not a video, I swear. And what I was doing, it was saying like, well, it's in the field of view of my camera. So that's what my user want to interact with. So from now, all the gesture on the phone were applicable to this object that was manipulating in the 3D world. So that's why I still put UI gesture here. And all the device field of view or position, like based on what I was doing with the phone, I could have shake the phone to do stuff, even if it would probably be a weird thing to do. And then, once again, you convert back and forth between the real world, the SwiftConf world, the device, the SwiftConf world, and the ARKit world. You convert all those points with those convenience method. And then, ARKit do the rest. I'm going to press the Apple way. ARKit do the rest. So, once again, let's see some code. So, if you're on a fixed position, which is really not interesting in that case, but for example, that box, well, I create a geometry of a box with a width, a height, and a length. No chamber radius, so no corner, like rounded corner. Oh wait, it's a really long line after. So basically, like there's some convenient thing because they say it's a box. You could put the first material and you apply it on all the side of your dice or your box, whatever. Then diffuse.content, and here you can put a color, you could put a layer, you could put a texture. Here I put red, because I'm a designer. And then you create the node with that geometry, you position it. Here I position it. Remember, my camera was the source, the root point. So I just put it in the 0 on X, 0 on Y, and -1 on Z. So it's just 1 meter away from my starting point of the camera. Of course, like if the session to start and then I move right over there, well, it might not be exactly where I want it to be, but that's the basic idea. And then sorry, in this case, I did not do that, so you didn't heard what I just said. Okay, she disturbed me by coming back, so you know, thank you. And so I added here like to the scene view point of view. So it's actually always updated this point of view to be the point of view of the device, not keeping in the real world, but related to the device. So that box just going to stay in front of you like a square, because it's in 3D, but you just see it from one side like this. Not really fun. You could make it turn. Still not really fun, but good to know. And after, once again, it's a UI label. So the SwiftConf at the bottom is also just a UI label in this view. After, relative to the initial position of the camera, so that's what I wanted to say. So you already heard it, kind of. So here I added not to the field of view, but the root node. And the root node is where my camera started. So now this little plane, like given the sample demo, obviously, I didn't design that plane. Well, it's just going to stay here now forever. So once I start my camera, I put the plane here, how much, 1 meter away from me, and after I move, and it still just stay all around here. You look really dumb when you look in the AR presentation, I'm sure. After, relative to the real world, so as we saw with those boxes, I didn't put any content in the space, I put them in the world in that SceneKit demo. So here, a little more code, and I have no idea how much time left because the counter just fucked up when okay. So relative to the real world. So here, the first thing is like, you set yourself as a delegate of the session. You always want to set up those delegates. There's always good information to get from those. And you set up a configuration. We're saying, I want to detect plane, like horizontal plane, and you start the session. At one point, you will be called back by the delegate of the session, saying like, hey, I found something. I found an anchor for you. And you check, what, is it an AR plane anchor? You sure you detected a plane, not a weird other object that you don't detect yet? So yeah, it's a plane, but you still check it. And then you know there's a plane. From now on, you can, that's what I was doing with my focus square. There's a bit more code in that one, so obviously it's not there, but that's the same idea. Then when we tap, well, I take the location of, I don't care where the guy tapped. I was just considering that the center of the screen that matter. Because you have to consider it's double interaction here. Already, just for me as a developer, it's complex to know what's going to happen. I just say, no, you tap on the screen when you have a location. That's the center of the location that matter, not the tap. Where is the tap on the screen? So you have to simplify, I think, what this new game controller mean. Then I do a hit test. And we'll see it's weird in SceneKit because you have different type of hit test. This one is about hit test in ARKit. In the real world. So same thing, you throw a ray of light and you try to find existing plane that have already been detected. You find some, you take the first anchor, you create a box. Then you have something like a little voodoo dance to do, but it's not really complicated. Basically what you do is like, you take all the information of the transform of the anchor, and because, I don't know why, but there's probably 12 different objects to say the same thing, which is like, matrices 4x4, CNC vector 4x4, CG matrix 4x4, and basically you just do a dance to convert them in the other one, but they mean the same thing. They're just a bunch of numbers that allow you to do a rotation and transform and so on, rotation, translation, and so on. And then I add it to my root node. So my anchor was here, so it contained all the information of where that space here compared to my root node. So now I add it, well, it's going to stay here forever, even when I move my phone. Interact with the content. So once again, like I say, you can do like a gesture, you get the location in the scene, and then this time you do a hit test, it's not the same hit test. This one is a SceneKit hit test, not an ARKit hit test. When you first try to do code completion because it's the same class. You have both of the it tests. It's really easy to be confused. Well, no, there's just one for ARKit, one for SceneKit. And this one you're saying, well, I have a location in my screen that I've just been tapped in 2D. Find object, not in the real world anymore, but in my scene that I've already positioned, that matches ray of light once again. And then you get like 1, 2, 3, 4, whatever number of results that order in the Z index. So the closer, the first one going to be the closer. And you get the result, which is a node. And so then you can like do something. I was saying like, well, now the gesture are related to it. You can change the color, whatever you want to do. That's an interaction. After, you can also interact, I would say, more with ARKit, not SceneKit, with, like I said, the field of view of the device, which is what they call the inside frustum. So here what you say is like, well, I want my current scene point of view, which is, the point of view is basically like, once again, like, where is a point in the space regarding my device? And I'm going to say, like, what do you see in that field? Which node can you find that are in the current space of what the user is seeing? So here you had a bunch of nodes. In my case, I had one little box. And that's not necessarily an interaction in it, but that's, you find an object. So after, same thing, all the gestures, the pinch, or whatever, apply to that object that you just found. And that's all. Now the limitation. Well, as I say, it sucks. You have only horizontal plane detection. I already know they were lazy at Apple, but not that much, because it just looked clearly the same to me. If you do like this, it looked like a ground, to me, at least. So I don't know why they do that. No, I do know why they do that. There is a little thing in UI, in AR, which is like gravity. So basically, when you start a session, you assume that you want a gravity session, which means like even if your phone is here, you know where the ground is because you have a sensor, you have like a geometer or whatever. Remember that thing that tells you where the ground is. So that's why it's easier for them because they know here, when you're oriented like that, they know that it should be there exactly, the ground. But it sucks, but it's an enum. So, you know, if otherwise they will have put a Boolean, or they're just trying to fuck with their mind again. After, it's an unstable API. So since I started to work on that talk, which is Friday, it probably have changed 3 times. And they just change stuff around. Well, you know, wait for the golden release and pray. But that's what it is to play with beta stuff. It's also really hard to test because in order to do that, demo was way harder than the SpriteKit demo. Because in SpriteKit demo, I could do it really weirdly in my underwear at the hotel room, in the hotel room. And it was easy, like even if I didn't have space, I will project space in the void in front of the hotel, I didn't care. But for SceneKit, it's hard. You need to do the ground detection. Well, you do need a ground that is detectable and you do need some space. So, and you do need to find that space. So if you say like, well, fuck, it didn't work, I want to start again, well, you need to detect the ground again and wait and then put your object and so on. So it's a bit like annoying to test and forget about like any UI testing on that. Well, I will not do UI testing on ARKit, and also obviously no simulator and so on and so on. And after, well, it did work quite good right now, but it's not always good. Sometimes you have a box here and like, oh yeah, that's cool. And you're like, where's my box? Yeah. Oh, it's over there. Yeah, of course. So it doesn't always work. And it's for real world and even like space world. So even if you put something here, you will go back and sometimes it's like, just there. Well, because it's hard, you know, so there's limitation. And after going further, well, there is interface, human interface guideline with ARKit that are like awesome, and I haven't read them. And from Apple, that say basically you should not do this, you should not do that, don't do this, and do this like this exactly. Then there's this Twitter thing with made with ARKit, which is way better than my demo. But it's way depressing because you're like, I'm never going to be able to do that. And obviously, there's all the WWDC sessions that are great and all the Apple docs that are awesome. And thank you, Apple, and so on and so on. And that's all. So thank you for your time.
Wow, that was pretty cool. Actually, you made it me want to do something with ARKit, but I guess I'm not the only one here. Because when we hear the first time about ARKit, we think about this crazy second world, so to say.
Yeah.
But you made it very very real.
Yeah, and it's really easy, seriously.
Yeah.
I'm not good. I swear I suck. So
You practiced a lot. Talent is
yes,
overrated.
yes.
Yeah.
I broke a lot of pot.
Yeah.
Not smoke it.
Do you want to show that last slide or not?
No.
Okay, it's better.
You convinced me. You see, that's why I put it in the end.
It's a funny one.
Nobody knows what we talk about.
Ah, okay, yeah. Well, maybe you show that after after the questions. Any questions? All right, TJ, I'm coming.
I thought we were over time. Maybe no.
It's okay.
It seems it seems like ARKit doesn't handle moving things very well. Like it wants static background.
Oh, yeah, if there's element moving in the real world.
Yeah.
I mean, so for example, plant detection, like I might have my kid that, well, he's moving, you know, a lot on the ground actually, because he's crawling. And yeah, it's true, like often like I will like, I will detect something and just pass in the field of view, and that just fucked it up. So it's true that if you have stuff moving in the scene while you're trying to detect, it will not work as well. And also, like, obviously, if you put your hand in front of it, as you said, well, the box is going to be on your hand because it's still going to be on the real position, but you have your hand in front of it. It's really weird. But they don't really do anything else than plane detection. So even if you have a bunch of stuff moving here, it doesn't matter. The object just going to be wrong. But they will never, I mean, I assume they will not fix that. Like if you have a hand passing in front of it, like trying to say, oh, well, you have a hand in front of that box. Not now, at least. We will have to wait a little bit for that, I guess. But yeah, thanks. No question, great.
No, I'm sure there's a question. Yeah. You're not going to get out with like one question.
I make it really long, hoping so.
I'm not sure if you have mentioned it and I missed it. Can I pass in real world detection? I put something on the ground. Can I pass the information to another phone that sees the object at the exact same position?
Okay. Well, no. In short answer. So there is in other AR device in the SLAM, which SLAM is like all the technology of AR. What they call ground truth. We can say like I'm here, and not like collocation style, but almost the same thing. Like that's where I am. That's a position that is absolute. In ARKit, it's just related to you. So your camera. So the other phone not going to know where that camera is. If you were to do a link with an AR anchor at a synchronized time, for example, you can imagine like you put the two phones at the exact same position, and then you move them from that, but you still have this anchor point that link them. Maybe, but you know, there was way around.
Another question in the same respect. So this means when I just put an object on the ground, switch off the telephone, go somewhere else, come back, the object is gone, right?
Yeah. So the dirty little secret is like your anchor will be gone, but not necessarily the scene. So you could like technically when you go in the background, you go back again, the scene is still there, but the anchor don't mean anything anymore because your phone have moved, but the math haven't moved. They still at the old math, so that just don't mean shit. If you were to position your content relative to just the phone itself, well, even if the phone starts to be here, it will be true because it's just in front of it, but that's not really AR. There is probably ways around, and I'm sure Apple will like, you know, like that's what they did, for example, like there is some, I can't remember what is that techno that it's not for, so BLE, for example, for Bluetooth, I just said I work on that, so I should remember. When you have a device and you communicate with it and you go in the background, you can put this mode in background mode, and the device will receive information, treat them for you, and call you back if there's some interesting one, for example. I could assume that if AR starts to be big, Apple will want to do that, saying like, well, even if your app is in the background, I'm going to continue saying like doing like core motion processing. Then when you start back to session, I could just roll back all the math, fast forward all the math, sorry, I guess. Yeah, so.
Thanks.
Welcome.
All right, we're gonna go to the next break. Yeah, I was just thinking. I also did a few things with Blue BTLE here at 7P, and I can tell you a little bit about that later. And I will soon do BLE again, so it
With
means
AR.
that not with AR, which means that you will see a lot of me coming on iMessage or something like that, asking you questions.
Yeah.
That's what you get for knowing me.
It's too bad my phone screen doesn't
I still
work.
wanted to press on that key because when I saw the last slide, I almost died.
No.
What?
I'm gonna cut it off.
No, it's a nice slide.
Yeah. He made it. He made it. I swear
I
he
didn't.
made it.
I
He
didn't.
just edited my slide. He said, Hugh, I'm going to get back to you to be a BLE expert. That's what he did.
And it's funny because it's just after Manu from Microsoft left.
That was for her. That's why I cut it off.
All right. Let's take a break because we're running late, but it's okay until take a big 10 minutes or something like that. And I'll call you back anyway. And we'll have the last presentation from Gianluca about server-side Swift. All right. Big round of applause again.
Thank you.
For the frog of the year.